Hi, my name is Yuki Macias, and I'm the project manager as well as the research manager.
Hello, my name is Arlene Cruz, and I am the project coordinator and creative design leader.
We are from the Young Women's Leadership Academy here in El Paso, Texas, and our project name is Go Green or Go Home. We are the green side.
Okay, so our project initially started when we joined a green architecture course. We discovered 3D printing was being explored in the construction industry. This led us to question whether plastic could be used and to potentially replace wood in the construction industry. So what we decided to do was test whether wood was as sustainable, if not more, than 3D printing. Originally, we did believe that the 3D printed structure was going to be a lot stronger or more durable. And so what we did to test this was that we created a wooden structure and a 3D printed structure, and we measured these after being exposed to certain conditions. These conditions being heat exposure and structural erosion. What we did in order to test this was we exposed them to extreme heat and to water, and then we put them into a machine that would compress these structures. After we compressed these structures, what we did was that we measured the load in pounds per square inch. Then we compared each structure to see which one was better, and in the end, came to our conclusion.
Our project consisted of building a 3D printed house. We used a program called Tinkercad, which then we transferred it into a MakerBot. MakerBot allowed us to 3D print the actual structure. And for the wooden houses, we took a weekend to measure all symmetrical walls so that the structures could be. Then we measured, or through the compression machine, we used it to measure load. Load is measured in PSI, which previously mentioned is pounds per square inch. We had two controlled. So we had a plastic controlled as well as a wooden controlled. Our plastic controlled sustained more load than the wood. So our hypothesis was proven correctly with that trial. Then we submerged our plastic and our wooden structure into a bucket of water for 30 minutes. After 30 minutes, we noticed that the pressure of water had actually opened up the wooden structure. So obviously, pressure of water affected the wood enough to make it weak. Well, the plastic didn't really get affected by water. Instead, it sustained more load than the wood. And then our third one was putting it into an oven. The oven was heated to 250 degrees. And that was to simulate the heat in case of, because we know plastic can melt. So we wanted to test it to make sure it wouldn't actually melt while it was a structure. And we did notice it did melt, but it didn't melt to the point where it completely went flat. Instead, when put under the compression machine, it compressed to the point where it was melted enough. Instead of actually having a rupture, it compressed into a smaller box. Our results, as previously mentioned, the plastic did sustain more when controlled. It sustained less when put under heat, but when submerged, it sustained a lot more than the wood. So in conclusion, we can say, results, as you can see in our presentation, we actually had to measure the void because we did notice that our houses have a space in the middle. So how the compression machine measured it was if it was a solid cube. So what we had to measure was the width of the wall to find the area, and then multiply that by 4, and then divide it by the pounds it sustained to find the load. In conclusion, we can test that our hypothesis was correct, that 3D printing can be used in construction in the future based on the trials that we conducted. Of course, we know that more trials would have to be made in the future in order for this project or to be more effective, the 3D printed house to be more effective. But we did prove that our hypothesis was correct and that 3D printing could be a future project that we might include in construction.
These are some of the resources that we used, some of the links that we went into in order to do our research. In this research, we found that approximately 14 tons of plastic are being thrown into the ocean. So what we came up with was that maybe we could use this plastic to create the filament for the homes, for the 3D printed homes, instead of using the wood. We found out that a lot of the wood that is being used right now is causing small but at the same time big amounts of deforestation. Although the percentage may seem small, once you compare it to everything that all the trees that are being cut down, it is a pretty big percentage. So we thought maybe replacing this wood with a 3D printed filament could help not only reduce the pollution, but also the deforestation occurring at the moment.
And then we would like to acknowledge our experts. We had 3 experts. Our first expert was Ruben Valientos. He helped us by allowing us to interview him before actually conducting the experiment. He answered our questions that we had before the experiment and helped us with our hypothesis in conducting that maybe 3D printing would be effective in the future. Our second expert was Oscar Valencia. He helped us conduct the actual experiment. He was the one that allowed us to complete this project safely without hurting ourselves, since a compression machine is something that we had never used. And the oven was different from an industrial oven of the one found at your house.
And our last expert was Oswald Garcia. He assisted us in presenting and gave us feedback. He kind of guided us into how to present better, how to get our message through, and kind of how to explain our project better to you.
Thank you for listening to our presentation. We look forward to answering your questions.
Thank you.